Hi, we are the contact lens dry processing team, a multidisciplinary biomedical and mechanical engineering senior design team in the Kate Gleason College of Engineering. Throughout this project, we work closely with global contact lens manufacturing company Bausch+Lomb, which has an R&D and manufacturing facility here in Rochester, New York.
Our team is composed of mechanical engineering students Jason and Caius and biomedical engineering students Taylor, Connor, and Priya. What are contact lenses? Contact lenses are small, convex plastic discs that are worn directly on the cornea of the eye and are used for vision correction. Contact lenses are prescribed by an eye doctor and are typically used as an alternative to eyeglasses.
Shown in the diagram is an overview of the contact lens manufacturing process. We are focused specifically on the dry processing step, which is the method of removing a cured contact lens from its mold pair. There are several steps in the dry processing process as outlined in the diagram below, but the two main actions are decap and dry release. Decap is the action of removing the top mold from the mold pair, exposing the lens that remains in the bottom mold. Dry release is the action of removing the lens from the bottom mold. Once removed, the lens moves to extraction, which is the next step in the production process. During new product development with a unique contact lens material, Bausch & Lomb experienced decreased yields, forcing longer processing time using their existing dry processing method.
Our goal is to deliver a new process workflow with the potential to be implemented onto Bosch and Lomb's current manufacturing equipment. To meet this objective, the alternative methodology must maintain or improve dry processing yield, reduce processing time, and demonstrate feasible manufacturing integration without negatively impacting lens dimensions, cosmetics, or material properties, and without hydrating the lens. Even at the proof of concept stage, the solution must remain mindful of material waste and energy consumption to ensure it is viable beyond the benchtop. Our testing approach focused on identifying the most critical steps in the dry processing workflow and evaluating alternative solutions to improve performance. We used a design of experiments methodology to structure our testing and ensure that our results were statistically valid. The key measurements included preferential release, which confirms whether the lens remains in the bottom mold after decap, and degree of edge lift, which is graded on scale of how much lens mold separation is present at the edge of the contact lens.
For this project, we faced several challenges that pushed us to adapt and rethink our approach. During initial testing, data review of the component of the process we were focused on was no longer facing issues. This required us to revisit preliminary brainstorming of new ideas. Although it set us back, it helped us better understand the manufacturing workflow, just how much interaction there is between processing steps. All testing on the benchtop comes with risk of whether or not the results will transfer to the manufacturing line. A lot of our testing was manual using the equipment shown on the previous slide, which adds difficulty with repeatability. To support our experiments, we designed and modeled several pieces of tooling using computer-aided design software. These designs are intended to vary from the tooling used on the manufacturing line to allow for alternative solution concepts to be tested, and for it to fit within our benchtop equipment. We use 3D printers with ABS plastic to print and test our designs. This is a cost-effective way of making iterative changes to designs as we test and collect data.
We would like to thank Bausch& Lomb for sponsoring this project and providing us with the resources necessary to understand the process and complete our testing. Thank you to Kyle Reeser, a subject matter expert in contact lens manufacturing and the client representative for this project. And thank you to the MSD department and our MSD guide, Alan Dawson, for their oversight and support throughout all phases of this project.